Hi, welcome to section 6.2 of part 1. We're going to go right from chapter 7 to chapter 6, and we're going to start talking about this idea of conic sections. I should have already shown you the introduction video. Basically, you should have seen this shape here, and basically what we're going to be talking about are sections of cones. Therefore, why it's called a conic sections. We're taking out slices of cones. Okay, and the first slice we're going to talk about are circles, and circles are very important. When you take the ACT test, there's a lot of questions sometimes on circles. So basically, what we're going to do is we're going to find equations of circles, and we're going to find the coordinates of any points where circles and lines will meet. Okay, so that won't make really any sense until we actually get into this subject. All right, so the first slide is basically just telling you the definition of a circle. Hopefully this makes a little bit of sense. It's a perfectly round shape. It is a line that is curved so that its ends meet. Okay, so there's no breaks in a circle. Circles are complete shapes. And this is the important part. And every point on the line of the circle is the same distance from the center. Okay, that's very important. So what does that mean? Okay, so if we have a circle. Okay, this point right in the middle is called the center. And then we also know that from the center to the circle, anywhere that we look, okay, so if I take a line from the center to the side of the circle, what do we know about all these sides? Okay, those are all equal. They should all be equal. And these sides are called the radius. Okay, so that is what a circle is. It's a bunch of points that are the same distance from the center of the circle. And when you combine all these points together, you have a circle. Okay, that's all basically it is. All right, so circles have an equation. It's a special equation. This one that we're going to look at is called center radius form. And it's called center radius form because it's very common sense here. It tells you what the center is, and it tells you what the radius is right in the equation. Okay, so this slide is basically just so you can have the formula handy, so you know where it's at. All right, so let's look at the equation again. So this is the same equation from the previous page. All right, so if we look at the r on the right-hand side, what does little r equal? Okay, little r is your radius. All right, and what about this h and the k? Well, if we put it in an ordered pair, the h and the k are the center of your circle. Okay, and we'll do an example here up above. Okay, so for this particular equation here, okay, so here's an example of a circle equation in center radius form. It's going to tell us our radius. Okay, so let's figure out what our radius is here. Now notice, this says r squared is equal to 9. So if r squared equals 9, how do I get r by itself? I have to take the square root. So the radius of our circle is 3 units. Okay, so the radius of this particular circle is 3 units. Now, why did I not use the -3? Because the square root of 9 is also -3. Just remember, distances can never be negative. So we always have to use the positive version. Okay, so the number after the equal sign helps us get you radius. Now let's look at our center of our circle. Okay, so we use these two numbers to get our center of our circle. And hopefully you remember when we did our quadratic chapter that you always use the opposite sign. So if it says x minus 2, you're going to use positive 2, and if it says positive 1, you're going to use negative 1. Okay. So there are the two pieces of very important information that you have. R equals 3, so I'm going to write this down here. And our center is 2, -1. All right, so we can plot this very easily. Our center is 2, -1. And then every radius is equal to 3 away. So if I go up 1, 2, 3, if I go 1, 2, 3 to the right, if I go 1, 2, 3 to the left, if I go 1, 2, 3 down, this should form a circle. Okay, so let me draw this. Hopefully this will work. And there we have it. Okay, so that is a circle with a center of 2, -1, and a radius of 3 units. Okay? Okay, now what happens if our equation looks like this? X squared plus y squared equals 16. So what do we notice is missing? Hopefully you notice that there are no h and k in your problem. Okay, so all this means is that your center is at 0, 0. So when there's no h and k, it just means that your center is at 0, 0. So that's actually kind of an easier problem. So for this particular example, if we know the center is 0, 0, we can also figure out the radius. Remember, r squared equals 16. So to get rid of the square, we take the square root. Square root of 16 is 4. Okay, so this one is going to have a center at 0, 0 and a radius equal to 4. Okay, so my center is right in the middle, and I'm going to go 4 to the right. I'm going to go 4 up. I'm going to go 4 to the left, and I'm also going to go down 4 and sorry about that. And I'm going to draw my circle. And there it is. Okay, so that was nice and easy. So if you do not have an h and a k in your problem, you should assume that the center is at 0, 0. All right, so example number 1. It says find the center, and it says find the radius of the following equation. So center equals, radius equals. All right, so remember, it's the opposite number. So if that's positive 3, we're going to use negative 3. And if this is negative 6, we're going to use positive 6. So our center is at negative 3, 6. And our radius, so remember, this number is equal to r squared. So to get rid of the power of 2, I have to square root both sides. So now, should we use square root of 45? Okay. If you're in geometry, I'd just say, yeah, let's use square root of 45. But you guys are advanced. You should be breaking this down. So hopefully you know that 9 times 5 is 45. And the square root of 9 is 3. Oops. Sorry, made a mistake there. So square root of 9 is 3. Square root of 5 cannot be simplified, so I just bring it down. So my radius is 3 root 5. Okay. And if you were to graph this, all you'd have to do is do 3 root 5 on your calculator and come up with a decimal, so you know where exactly that will go on your graph. All right, so example 2 kicks it up a notch, definitely. Okay, it says put the following equation in center radius form and then find the center and the radius. Okay, so what I've done here is listed the steps on the side. There are 3 steps. Okay, so step 1 says to get the constant, get rid of the constant. So I need to take negative 12 off of the left and put it on the right. So I'm going to add it to both sides. So I'm going to equal it to 12 because I'm going to add 12 to both sides. Okay. Now I actually should probably actually add a step in here. Let me add one. I'll call this 1A. Combined x's and y's. Okay, so our step 2 is that we're going to combine our x's and our y's. So all that really means is we're going to rearrange it and put the x's with the x's. So over here, I'm going to put the x squared and my negative 6x together. I'm going to put a parenthesis around it. And I'm going to leave a little bit of room. And then I'm going to do my y squareds together. I'm going to put these in parentheses. Plus 4y. I'm going to leave a little bit of room, equals to 12. Okay? So we've combined our x's and our y's together in one area. Okay, so step 2 says now add b divided by 2 squared to both sides. So that should look familiar. We did that when we were completing the squared. So we're going to take our b value. Let me get a different color here. So our b, we're going to add b divided by 2 squared to both sides. Okay. Okay, what's our b in this one? It's negative 6. And our b over here is positive 4. Okay, and if you do that to both of these, Okay, if we do it to the left, we have to also do it to the right. So what are we going to add over here? Negative 6 divided by 2 is negative 3. Negative 3 squared is 9, so we're going to add 9. And 4 divided by 2 is 2. 2 squared is 4, so we're going to add 4. Okay, now simplify everything that we see here. So x squared minus 6x, this is equal to 9 plus y squared plus 4y plus, this is equal to 4, equals 12 plus 9 plus 4. 9 plus 4 is 13. 13 plus 12 is 25. Okay, so that's step 2. So basically we're just doing it 2, completing the squares in one problem. Okay, so number 3 says factor the left. All right, so the factoring it shouldn't be that hard. You're going to have a set of parentheses and a squared, a set of parentheses and a squared equals 25. All right, so I'm going to put my x, I'm going to put my y. What two numbers multiply to be 9 and add to negative 6? Multiply to be 9, but add to negative 6. Hopefully you see negative 3. And what two numbers multiply to be 4 and add to 4? Hopefully you see that's 2. So what two numbers multiply to be 4 and add to 4? Okay, hopefully you see that that's a positive 2. So if you notice now, this equation is in center radius form. Okay, and then the last part of the question says, what is the center and what is the radius? Okay, so center, opposite of negative 3 is 3, opposite of positive 2 is negative 2. So the center is at 3, negative 2, and this is equal to r squared. So if I take the square root of both sides, what is r? Square root of 25 is 5. So there is the answer to the second portion of the question. Okay, that one's a little tough, so we'll get used to doing those tomorrow in class. All right, so example 3 says, graph the equation from the previous example on your calculator. So this is the equation that we got after we had done the problem, and I need to be able to teach you how to plug this in on your calculator in order to graph it. Okay, so that's what we're going to do. So we need to get y by itself. So in order to graph a problem on the calculator, we need y. So I'm going to subtract this whole x minus 3 squared from both sides. Okay, we can do that. Okay, that's gone. So y plus 2 squared is equal to 25 minus x minus 3 squared. Okay? Okay, now how do I get this power of 2 out of here? Okay, so basically I have to square root both sides. Power of 2 and the square root go away. I'm left with y plus 2 equals square root of 25 minus x minus 3 squared. Okay, and then the last step is to, how do I get rid of the plus 2? I would subtract 2. Now I'm not subtracting it inside the square root, I'm doing it on the outside. So y equals square root of 25 minus x minus 3 squared. Close your square root, minus 2. All right, so let's graph this on our calculator now. I'm going to make this a little smaller. Okay, I'm going to open up my calculator, and let's plug it in here. So I go to y equals, I get rid of everything that's there, square root of 25 minus x minus 3, close my parentheses, squared, close my parentheses to stop my square root, and then I'm going to minus 2. Okay, so let's see what we get here. Okay, so what's the problem? I'm not on my main screen, so I go to zoom 6. All right, so what do you notice? Okay, we have a problem. We only have half of my circle. What did we forget to do in the actual problem? Okay, if you go back here, anytime you take a square root, you have to use the positive and negative. So if you notice here, I only use the positive version. So I have to do the exact same equation, but I have to do the negative version of it. So I'm going to go down to y2 and I'm going to do the negative square root of 25 minus x minus 3 squared, close my parentheses, minus 2. Okay, and when I graph, that will give me my circle. Now, if you notice, it's not closed. Okay, the pixels on the screen sometimes are tough when they're doing circles. So there's a couple ways you can try to get rid of this. You could go to zoom, sometimes decimal. We'll get rid of it if we go to zoom 4. Okay, it made the screen a little bit too small, but if you notice that the gap is still there. So I'm going to go back to zoom 6, and then sometimes we can go to zoom square, zoom 5. Sometimes that will take care of it. Okay, it's actually a little bit better on the left, it's a little bit better on the right. And then sometimes we can go to zoom trig. Sometimes zoom 7 might work. Yeah, that one didn't work too good. But you get the idea that's what graphs a circle. You have to do the positive and the negative. Okay, and we'll talk more about this graph when we get into some more questions. Okay, all right. So last example. It says find the coordinates of the points where the following two equations intersect. Okay, so what we're going to do is use our calculator to do this. Whenever we're trying to find intersection points, we're going to use our calculator. This one is good to go. This one, however, we need to solve for y. So I'm going to do a couple things first here. I need to subtract x squared. X squareds go away, so y squared equals 25 minus x squared. I need to square root. So y is equal to plus or minus 25 minus x squared. Okay. So there are my three equations. Okay. So let's go back to my calculator. I'm going to plug in my new equations. Okay, so the first one was 2x minus 2. My other two were square root of 25 minus x squared, close my parentheses, and then I had to do the negative version of that, negative square root of 25 minus x squared, close my parentheses. Okay, and then I graph. There's my line, and there is my circle. So we do it the same way we used to. Second trace, let me get rid of this. Okay, so second trace, I go down to intersect, enter, and I'm going to move my cursor to the graph that I want to see first. So I hit enter, so I'm going to move it up to the right. So I hit enter, it moves it to the circle, I hit enter, I hit guess, I hit enter again. My first intersection is 3, 3, 4. Okay, so my first one is 3, 4. Okay, let's try a second one. Second trace, go down to intersect again, enter, and now I'm going to move my cursor down to the other point that I want to find. So enter. Now, we're on the top part of the circle. We want to be on the bottom, so I hit up to get down to the correct one. And you want to make sure you're on the circle for the second click. So up and down will move it from shape to shape. So enter again, enter on guess. Our second point is negative 1.4, negative 4.8. So negative 1.4, negative 4.8 is our second intersection. Okay, so there you have it. That is circles. Make sure you know your equation. We'll do more examples tomorrow in class so hopefully you'll have a better understanding of this, but circles are very important. Thanks for listening. See you tomorrow.